Okay, so we're going to start kind of a different branch of mathematics now. We've been talking about sequences and summations and things like that, and a lot of times we include these principles along with that, but they really have to do with probability. And so we're going to do a little bit of that in sections 8.6 and 8.7. And, if you go to a university, like I went to Cal State, they offer a whole class in probability, which I loved that class. I thought that was the funnest class I took. Um, but it's a different branch of mathematics. So here we're just going to give you some basic principles and an introduction. So let's say you're going to make license plates, and let's say you're in the state of California. Well, in California, we have a number, right, for our license plates, like on a car, and then you have a letter, and then you have another letter, and another letter, and then you have a number, and a number, right, like digits. Okay, so that's how our license plates for cars are made up right now. So there are 1, 2, 3, 4, 5, 6, 7 parts to that to that license plate. Well, how many license plates can we make? There's 26 letters in the alphabet. We have 10 digits, right? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's how we're thinking of it in pieces, okay? So we'll come back to this at the end. Now, an easier way to demonstrate what we're talking about is you have you have choices, right? Like, let me go back here a minute. So you have choices for the number, the first number. It could be a 0, it could be a 7, you have these choices. Same thing happens at like your student ID number. There are choices for each place in your student ID number, right? So you have digits that you could choose from. That's how we get different license plates, different student ID numbers. Everybody has a number associated with their name on campus, a student does anyway. And for cars in California, every car has a license plate that goes specific to that car. Okay, and it has to do with choices. So to break this down into a simpler example, we're going to think about getting up, getting dressed in the morning, and you're going to wear a pair of jeans, you're going to wear a shirt, and you're going to wear shoes. Okay? All right, so those are your choices that you have that you want to know how many like different outfits could I come up with. So here, here you are as a person, right? You're gonna wear a hat and you're gonna get ready for the day. And so what do you have choices for? Well, you could wear, your blue jeans. I'll say blue. I won't draw jeans. Or maybe you have a black pair of jeans. So black. Probably should do white. Then I could use B and W, right? Okay. Let's make it white. I have a pair of white jeans. And then you have shirts, right? So maybe you have 3 shirts. Maybe you have a red shirt, a yellow shirt, and a pink shirt. Okay? And then, so you could wear your blue jeans with a red shirt, or you could wear your blue jeans with a yellow shirt, or you could wear your blue jeans with a pink shirt. But you could wear your white jeans with your red shirt or your yellow shirt or your pink shirt, right? So we get this kind of branching out thing. Now you have 2 choices for shoes. Let's see, what color of shoes should we have? Green shoes, because I need a different letter here. Green shoes and let's see, all the colors I can think of start with B. Let's say amber. You have amber shoes. Okay. So you could wear your blue jeans with your red shirt, and then you could have green shoes or amber shoes. Okay. Or you could wear your blue jeans with a yellow shirt, and you could have green or amber shoes. And then you could wear your blue jeans with your purple shirt. Oh, no, it was pink, sorry. Pink, and you could have green or amber shoes. Okay. And the same thing over here with your white jeans. You could go white shirt, red, or white jeans, red shirt, and you could have green shoes or amber shoes. And then you get this kind of tree showing you all the choices, all the different paths you could take. Okay, so the way we would follow that is you could do blue jeans with red shirt, green shoes. That would be like a BRG combination. Or you could go BRA. Or you could go B yellow G. BYG. Or BYA. Or you could go B he, oops, you go blue, pink, green, or blue, pink, amber. Okay, those are all your choices with blue jeans, right? So you get that many combinations. Or you could go white jeans, red shirt, green shoes. White jeans, red shirt, amber shoes. A white shirt, white jeans, yellow shirt, and green shoes. White, you get the idea, but white jeans, yellow shirt, amber shoes. Or you could have white shirt, jeans, pink shirt, green shoes, white, pink, amber. Okay, so there's all your combinations right there, and you can count them up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There are 12 different outfits you could have. Okay, so that's what we're talking about. And this is called a tree diagram over here when we write this out like that. And you can kind of follow the paths, like I was saying, to get those different combinations. Okay, um, there's an easier way to do it, and it's called the fundamental counting principle. So if we're going to use a fundamental counting principle, what we would do is we say, well, we're going to wear jeans, and we have so many choices. We're going to wear a shirt, and we have so many choices. And we have shoes, and we're going to have so many choices. So we had 2 choices for the jeans, we had 3 choices for the shirt, and we had 2 choices for shoes. Will you multiply these? Okay, so you just multiply 2 times 3 is 6, 6 times 2 is 12. That's the fundamental counting principle. Okay, so it all has to do with choices. Like you have events and you say, how many ways can one event occur? And then a second event, and then a third event. So our events here, we were picking out jeans, we were picking out a shirt, we were picking out shoes. How many different ways can that occur? Okay, this is called the fundamental counting principle, and we just multiply those up. Now, what's interesting on these problems in this section, they're really long to type up, but the work is really short. Okay, so next semester you're planning to take 3 courses. You're going to take math, English, and humanities. Okay, so those are the events. We're going to take a math class, an English class. Let me write this out a little bit. Math, English, and humanities. Okay. Based on time blocks and highly recommended professors, there are 8 sections of math, okay, 5 of English, and 4 of humanities that you find suitable. Okay, so you're going to pick one of these 8 sections for math and English, and or 5 for English and 4 for humanities. Those are your choices. Assuming no scheduling conflicts, how many different 3-course schedules are possible? You could make a tree, but I'm not going to because that'll just take a lot of space and I don't need to. So what my probability teacher, he would have us put blanks underneath what we're choosing. Okay, and then you filled in the blanks. So how many choices are there for math? 8. How many for English? 5. How many for humanities? 4. And then you're going to multiply these together. So let's see, 5 times 4 is 20, 20 times 8, that's 160 schedules possible for our 3 courses. Okay, so that's how we get it. All right. We'll do more in the next video.